Gear Patrol calls their new dive watch the best sub-$500 dive watch. Full stop. Men's Health rated them as the most stylish solar watch in the game. Who are we talking about? It's Movement. They're leveling up your gift giving with the sleekest watches you can buy and the biggest deals of the season. From their innovative ceramic materials to sexy automatic divers, from ultra-thin dress watches to solar-powered statement pieces, and everything in between, Movement is making sure you're the good gifter this year, for your family, your friends, or for yourself. And now you can take advantage of 30 to 50% off Movement's California clean watches, jewelry, and accessories to get them a gift they'll never forget. With fast, free shipping and returns and amazing bang for your buck, Movement makes for a relaxed shopping experience. And with one-size-fits-all watches, it's an easy, elegant gifting experience too. Shop 30 to 50% off now at mvmt.com. That's mvmt.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 25, Episode 107, for broadcast on the 10th of October 2022. Coming up on SpaceTime, Dimorphous grows a massive comet-like impact debris trail. Yet another planet found in the Proxima Centauri star system. And a new plan to keep Hubble flying. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The DART spacecraft impact into the asteroid Dimorphous has apparently generated a massive comet-like trail of dust and debris stretching back over 10,000 kilometres. The collision, which happened 11 million kilometres away from the Earth, was monitored by more than a dozen telescopes on the ground and in orbit. Astronomers are continuing to sift through the reams of data generated by the mission, which was designed to see what sort of an effect the impact of a 610-kilogram spacecraft, travelling at a relative speed of 6.6 kilometres per second, that's 22,530 kilometres per hour, would have on a 160-metre-wide asteroid. The massive debris trail appeared in images taken by the SOAR telescope in Chile 2 days after NASA's Double Asteroid Redirection Test, or DART spacecraft, was deliberately crashed into the space rock. Dimorphous orbits a larger 780-metre-wide asteroid called Didymos, and the impact is expected to change the little moonlet's orbit, moving it about 1% or roughly 10 minutes closer to its counterpart, depending on Dimorphos's composition and mass. 2 days after DART's impact, astronomers Teddy Carita from the Lowell Observatory and Matthew Knight from the US Naval Academy used the 4.1-metre Southern Astrophysical Research, or SOAR telescope, at the National Science Foundation's Cerro Tololo Inter-American Observatory to capture the vast plumes of dust and debris blasted out from the asteroid's surface. They saw a huge dust trail, the ejector that had been pushed away by the sun's radiation pressure, similar to the tail of a comet, stretching out more than 10,000 kilometres. Carita says he was amazed at how clearly he was able to capture the structure and the extent of the aftermath in the days following the impact. Knight says now begins the next phase of the work for the DART team as they analyse all the data they've gathered and the observations they've taken to determine exactly what really happened. The observations will allow scientists to gain knowledge about the nature of the surface of Didymos, how much material was ejected by the collision, how fast it was ejected, and the distribution of particle sizes in the expanding dust cloud. For example, whether the impact caused the moonlet to throw off big chunks of material or mostly fine dust. Analysing this information will help scientists determine the best ways of protecting the Earth from the threat of future asteroid impacts by better understanding the amount and nature of the ejector resulting from an impact and how that might modify an asteroid's orbit. 15 days before the impact, DART released the small Italian space agency CubeSat called Lycia Cube, which monitored the collision and captured images of the event. And in roughly 4 years from now, the European Space Agency's Hera mission will conduct a series of surveys of both Didymos and Dimorphous. Hera will also release 2 small CubeSats to study the asteroids close up. They'll be especially focusing on the DART impact crater. In fact, they may even attempt to land in the crater. So some interesting times coming up. This report from NASA TV.
Yeah. Oh my goodness. 8, 7, 6,
wow.
5, 4, 3, 2, 1.
Oh my gosh. Oh wow. Awaiting visual confirmation.
All right. Let's see. We got it? Waiting.
And we have impact. A giant leap for humanity in the name of planetary defense.
Woo. Fantastic. Oh, fantastic.
During impact, the curtains close on Draco feed. That raw joy from the team, years of hard work and the weight of expectation lifted off their shoulders. This is amazing. Really, This is a huge moment for the mission. Lots more work needs to happen in the days, weeks,
Absolutely.
months.
Now, as I always say, it's one of my favorite missions. Now is when the science starts. It just starts now. Now that we've impacted, now we're going to see for real how effective we were. We're going to train all of those ground-based telescopes on the Didymos Dimorphous system, and we're going to make measurements that will help us determine just what its orbit looks like now relative to what it was before. So it's going to be great. Very cool.
All right, this is when science, engineering, and a great purpose, planetary defense, come together, and it makes a magical moment like this.
Yeah,
really.
We're embarking on a new era of humankind, an era in which we potentially have the capability to protect ourselves from something like a dangerous, hazardous asteroid impact. What an amazing thing. We've never had that capability before.
Now, I'm here with Nancy Chabot, DART coordination lead. Nancy, talk about a moment. What is going through your head right now?
I mean, I'm just thinking, wow, that was amazing, wasn't it? We've been planning for this moment. We've been talking about it for years. At APL here, we've been working on this since 2015.
It's happened, and it is just incredible that as humans, we have done this. We did this.
We've been working on for years, and even before 2015, internationally, people wanted to do this. People wanted to take this first test. And then we finally did. Partners across the United States. We have actually 28 countries represented on our investigation team of scientists, telescopes on all 7 continents, everybody doing their part to make this moment happen. I know I'm really honored to be on this team, and I know other people on the team feel the same way.
And so now that we have confirmed impact, can you let us know what's next for this mission?
Well, I mean, I think I'm still taking a moment here, because this is a big deal. And this was a really hard technology demonstration to hit a small asteroid we've never seen before and do it in such spectacular fashion. But I know other scientists on the team like me are already pointing at those images being like, did you see that boulder? Did you see that smooth area? Did you see the shape? What does that mean? And Lycia Cube is flying by right about now. Their close approach, taking images, and they're storing them, and we'll get those in the next days. Telescopes here and in space are looking. They're looking at the brightening of the rock that's thrown off from that spectacular collision that we saw. And this is going to go on for weeks. And so there's still a lot of excitement to come, but nothing to take away from this moment.
Nancy, you mentioned earlier about some of the international collaborations. And could you give us an idea on kind of the scope of DART's mission, right? It's not just us in the United States that's focusing on this. So can you expand a little on that?
Yeah, I mean, planetary defense is really an international issue. We are all on this planet together, right? And I think it's been so great for this mission to really support and embrace that international cooperation for planetary defense so that we can maximize what we learn. And this idea came about from international scientists talking to each other, working together, in order to make this moment happen for NASA's Planetary Defense Coordination Office, building the spacecraft here at APL. But really, scientists around the world are ready to get study what did we do to Dimorphous, but more importantly, what does that mean for potentially applying this in the future? I mean, DART really is just the start. It's just the first planetary defense test mission. It was spectacular, and it's accomplished, and we'll figure out how effective it was. That's really what we're going to learn in the next weeks to come.
This is Space Time. Still to come, another planet found orbiting the Proxima Centauri star system, and a new plan to keep the Hubble Space Telescope flying longer. All that and more coming up on Space Time. Okay, let's take a break from our show for a word from our sponsor, NordVPN. When you sign up with NordVPN, you don't just get a virtual private network, which, as you know, in this day and age is essential. You get peace of mind, knowing that your identity, your bank account details, your personal documents and information, photos, in fact, everything that makes you you in our online world is safe from hackers. Let's face it, we've seen some instances just in the last few weeks where hackers have gotten hold of personal information and data, leaving people exposed and stressed out. You don't need that either. So, do need to do something sensible, like getting NordVPN. And as a sponsor of SpaceTime, they've got a really great deal for you. Just go to our special URL, that's nordvpn.com/StuartGary, and check out their money-saving packages which have been specially put together for us. What you get is the world's leading VPN service. You also get a tool that helps block malware. It'll also help block trackers and ads that you can do without. And it lets you protect your passwords and files. You'll get cloud storage as well, and all rolled up under the one low-price bundle. And the deal comes with NordVPN's 30-day money-back guarantee if you're not completely satisfied. So just go to nordvpn.com/StuartGary and click on the Get the Deal button. That's nordvpn.com/StuartGary and sign up today to get the best software in the business to help protect you and your family from cyber criminals online. And don't forget, you can also use the discount code StuartGary at the checkout. And of course, as always, we've included the URL details in the show notes and they're on our website. And now, it's back to our show.
This is Space Time with Stuart Gary.
Well, it seems the number of planets astronomers are detecting orbiting stars close to our Sun keeps increasing. The nearest star system to the Sun, Alpha Centauri, is now known to have at least 4 candidate exoplanets orbiting in the triple star system. Alpha Centauri is the more distant of the 2 pointer stars showing the way to the Southern Cross. Located some 4.37 light-years away, Alpha Centauri centers around Alpha Centauri A and B, which orbit each other, and Proxima Centauri, which orbits the pair, and at 4.25 light-years distant, is currently the closest star to the Earth other than the Sun. Like the Sun, Alpha Centauri A is a yellow dwarf star. It's about 10% more massive than the Sun and just over 1.5 times more luminous. Back in 2021, astronomers announced the discovery of a sub-Neptune-sized planet about 3 times as big as the Earth, orbiting within the habitable zone of Alpha Centauri A. The habitable zone is that area around the star where it's not too hot and not too cold, but just right for liquid water to exist on the planet's surface, liquid water being essential for life as we know it. Alpha Centauri A's binary partner, Alpha Centauri B, is an orange dwarf star, a little smaller and cooler than our Sun, with about 90% of the Sun's mass and about half of its luminosity. Alpha Centauri A and B orbit each other around a common centre of gravity every 79.91 Earth years, with the space between them ranging from 11.2 to 35.6 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, around 150 million kilometres or 8.3 light minutes. So the distance between Alpha Centauri A and B varies by about the distance between Pluto and the Sun and that of Saturn and the Sun. The third star in the system, Proxima Centauri, is a red dwarf star, only about 1/7 diameter and about 1/8 the mass of the Sun. It's loosely gravitationally bound to Alpha Centauri A and B, orbiting the pair at an average distance of 13,000 astronomical units. That's about 0.21 light years. Or to put that another way, it's about 430 times the size of Neptune's orbit around our Sun. It takes around 550,000 years for Proxima Centauri to orbit once around Alpha Centauri A and B. In 2016, astronomers confirmed the existence of an Earth-sized terrestrial planet orbiting within the habitable zone around Proxima Centauri, making it the nearest known extrasolar or exoplanet to Earth. The planet, known as Proxima b, is what we call a super-Earth with about 1.3 times Earth's mass. It orbits Proxima Centauri at an average distance of just 0.05 astronomical units, or about 7.5 million kilometres. And remember, because Proxima Centauri is a red dwarf star, somewhat smaller, cooler and less luminous than the Sun, that still puts this planet, Proxima b, within the star's habitable zone. Proxima b takes just 11 Earth days to complete each orbit around its host star. In 2020, astronomers combined several independent measurements to confirm the existence of a second planet around Proxima Centauri. The new planet, which was catalogued as Proxima Centauri c, has about 7 times Earth's mass and circles its host star at a distance of 1.5 astronomical units, with an orbital period of about 5.2 Earth years. That's similar to Jupiter's orbit around the Sun. Now, at the same time as Proxima c was discovered, astronomers were getting some faint but nevertheless interesting hints of a possible third planet in the system, a Proxima d. Now, these sheer follow-up observations have firmed up those earlier observations, suggesting that there is a Proxima d planet orbiting around Proxima Centauri. Proxima d is estimated to have about a quarter the mass of the Earth, and it's orbiting really close into the star, taking just 5.1 Earth days to complete each orbit. Now, being that close, that means surface temperatures would be somewhere around 87 degrees Celsius. Jonathan Nally, the editor of Australian Sky and Telescope magazine, says like Proxima c, Proxima d still needs to be confirmed by follow-up observations.
Proxima Centauri, a lot of people probably haven't heard of Proxima Centauri. It's a star, and it's just a little over 4 light years away, and in fact it is the closest star to our solar system. So ignoring the Sun, outside our solar system, it's the closest discovered star. And it's possibly not, I don't think anyone's quite settled on it yet, whether it's a member of the Alpha Centauri star system, but it's very close to Alpha Centauri, basically, which for a long time was considered the nearest star until Proxima was discovered.
There's enough orbital information about what Proxima Centauri is doing to suggest that it is in fact orbiting Alpha Centauri A and B.
Yeah, that has been the sort of majority view, I guess, for a very long time, but then some doubt was thrown on it, and that's good if that's the sort of majority view again, that it's part of the bound, gravitationally bound.
It's really hard to tell, but because 13,000 astronomical units out from Alpha Centauri A and B, 550,000 years to orbit the binary pair in the middle there. It's easy to understand why the debate continues.
Precisely right, because in order to determine whether something is orbiting something else, you really want to see it actually proceed or go along a substantial part of its orbit to sort of work out the rest of it. But if it's that far out and it's going so slow in its orbit, then, if you only have observations over a certain time period, then you get quite a lot of errors potentially in there. But anyway, Proxima's been known for quite a while now, so they're obviously settling down to say that they've got enough data to indicate that, it's looking like it's part of the Alpha Centauri system. So it's, as I say, Proxima is just a little over 4 light years away. Alpha's just the tiniest bit further than that in terms of light years. So it's very close to us. But it's a small star, and it's too dim to be seen with the unaided eye from Earth, but you can pick it out with telescopes. And the big observatories, they can pick it out quite easily. But even so, even though it's a small star, it does seem to have a few planets, or at least planet candidates, that need confirmation, including a recently announced third planet candidate. And it's catalogued as Proxima Centauri b, the planet, not the star. Proxima Centauri is the star, b is the planet, and it orbits very close to the star, if it is true and it's there and it's real. If it's true and it's there and it's real, get this. One of its years, that is the time it takes to go around its star, is just the equivalent of 5 Earth days.
Wow.
So we take 365 Earth days to go around our star. This one would take only 5 of our Earth days to zip around its star. That's because it's really close in towards its star.
And that compares to Mercury, which is, 88 days to orbit the sun?
80-something days, yeah, exactly. So this is very, very close to its star. And even though Proxima is a pretty small star, if you're that close, it's going to be quite warm, of course. So they've estimated that it might be around about 85 degrees Celsius or so on the surface. Now, that's hot by our standards, but,
there
it's
are
not
microbes who can survive in those sort of temperatures.
Yeah, it's not out of bounds that life of some kind couldn't exist on a planet like that if it ever got started or whatever. But anyway, that's a whole other story. Now, the astronomers detected this planet by sort of a traditional way, if you like, of detecting planets, and that is by looking at the slight gravitational tug it induces on its parent star, Proxima Centauri.
The wobble method.
The wobble method, yeah. They actually look at the star, not the planet. They haven't got any pictures of this planet. They're just inferring that it's there by looking at the star, and they see that the star sort of is moving on the spot with this sort of back and forth, shifting back and forth on the spot as this planet goes around. And this wobble is tiny. It's just 40 centimetres per second. And it just astounds me that at a distance of 4 light years, they can measure things to an accuracy of 40 centimetres per second. For those who are working in inches, 40 centimetres is about 15 inches or so? It's really, really tiny. But that's the sort of accuracy you can get with these amazing scientific instruments, including this particular instrument called ESPRESSO, which is an acronym for something. And it's mounted on one of the 4 telescopes of the huge, very large telescope array in Chile, where they've got beautiful viewing in this massive telescope and this really superb
The European
instrument.
Southern Observatory, which Australia is a member of.
Correct, yep. Yeah, the European Southern Observatory, fantastic, amazing place. They've got so many telescopes there and building bigger ones all the time. Now, it should be emphasised that at the moment this is still a candidate planet. More work needs to be done to confirm the discovery, and that basically just means repeating these observations over and over again until they eliminate any possible sources of error and just building up more and more data. But, pretty good if it's there, and the likelihood is that it is. So it's just this whole thing again that, I remember even, 25 years ago or so, talking to professional astronomers back there, and they were not doubtful but not hopeful of ever getting much information about planets that orbit around other stars. And look what we've got now with the telescopes we've got on the Earth and the instruments that we have, plus the amazing satellites they put up to detect the presence of these exoplanets, as they call them. There are thousands and thousands and thousands of planet candidates out there. And the answer is the age-old question of, was the solar system the only star system to have planets? And, of course, for hundreds and hundreds of years, all anyone could say was, well, we just don't know, because we don't have the technology to look at these other star systems and say one way or the other. And now it's routine. It's just routine. It's fabulous.
It's interesting the way they name their planets, isn't it? So Proxima refers to the fact that that's the star's name, Proxima Centauri. B, C, and D refer to the sequence in which the planets were found. So Proxima B, which is the super-Earth, about 1.3 times the mass of the Earth, orbiting half an astronomical unit out, astronomical unit being the average distance between the Earth and the Sun. And this is a possible habitable planet, and habitability means the temperatures and pressures would be right for liquid water to remain pooling on the surface of the planet. Then you've got Proxima C, 7 times the mass of the Earth, so it's a big place. It circles its star at a distance of 1.5 astronomical units, 1,907 Earth days, and that's too cold for life to exist because Proxima Centauri is a red dwarf. And now this new one, right in there, Proxima D. Wow.
Yeah, you'd have to also, I suppose, take into account if it's that close to its star, then there are other things to take into account rather than just the temperature. I think Proxima Centauri, I think I'm correct in saying it's what they call a flare star.
Yes.
So
yes.
It can flare up and put out basically big solar flares, which can do a lot of damage to anything that's close enough. And the magnetic fields and things, and the sort of rain of what we call the solar wind here in our solar system. So there are other factors in play there. Would it have a protective atmosphere, and would this planet have a protective magnetic field around it? We just don't know, but you would want to. I think you would want to have a good atmosphere and a protective magnetic field like Earth has if you are that close to a star.
The interesting argument that some planetary scientists are making now is that when we look at flare stars, these spectral type M red dwarfs, the flares usually happen at certain regions of the star above and below the equator. not right on the equator. So their argument is that because these things are happening at higher latitudes, they're not actually directly slamming into the planets orbiting them. That gives the planet a chance to have some degree of life.
It gives it a chance, but I wouldn't bet my life on it.
I think there's a lot of wishful thinking there too. Yeah.
Yeah. Well, I think they're trying to look for reasons why. I mean, and they could be perfectly correct. And it's good reasoning, but so I wouldn't bet my life on it.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. Still to come, a new plan to keep the Hubble Space Telescope flying, and the sun is getting a lot more violent as we move into solar cycle 25. All that and more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
NASA and SpaceX have signed an agreement to look at ways of developing a system to boost the Hubble Space Telescope up into a higher orbit using a man-dragging capsule. SpaceX and the Polaris program suggested the study to better understand the challenges associated with servicing missions. The 6-month study will collect technical data from both the Hubble Space Telescope and SpaceX's Dragon spacecraft in order to determine if it will be possible to safely rendezvous with, dock and then move the Space Telescope into a more stable orbit. Hubble has been operating since 1990 at a standard orbital altitude of around 540 kilometres above the Earth. But Hubble has no onboard propulsion systems to counter the small but nevertheless still present atmospheric drag effect in this region of space, which causes some minimal but nevertheless real orbital decay. Previously, NASA used space shuttle servicing missions to reboost the telescope back into its designed orbit. Boosting the telescope into a higher orbit can add years to its operational life. But unlike the Space Shuttle, Dragon does not have a robotic arm to grab and manipulate Hubble. Now, if nothing changes, Hubble is expected to remain operational until at least the end of the decade, with a 50-50 chance of being forced to deorbit in 2037. A 200,000-kilometre-long filament of plasma erupting from the surface of the Sun has triggered a spectacular coronal mass ejection. The joint NASA and European Space Agency Solar and Heliospheric Observatory spacecraft SOHO monitored the filament and the emerging coronal mass ejection in the Sun's southern hemisphere. However, the data stream suddenly stopped before the full eruption was visible. That means scientists have no idea exactly where the coronal mass ejection is heading. Meanwhile, NASA's Solar Dynamics Observatory spacecraft captured images of a solar flare as it erupted outwards, classifying it as a strong X1 event. Solar flares are grouped by intensity into C, M and X class, with X flares being by far the most powerful. Each group is 10 times more power than the previous group. So an X-class flare is 10 times more powerful than an M-class and 100 times more intensity than a C-class. And this wasn't the first big solar flare to be erupting from the Sun in recent days. 2 strong M-class solar flares were detected earlier, producing multiple coronal mass ejections. While solar flares are blasts of energy, coronal mass ejections, or CMEs, are large explosions of plasma magnetic field flux flying out into space from the Sun's corona by solar flares. If this solar storm material hits the Earth, it can overload or even destroy delicate electronics on board spacecraft, inflate the Earth's upper atmosphere, causing spacecraft to suffer orbital decay because of increasing atmospheric drag. It also inflicts higher radiation doses on astronauts aboard the space station. It affects telecommunications and navigation systems, forces airlines to reroute flights away from polar routes, and it can trigger power blackouts on the Earth's surface by overloading electricity grids and blowing transformers. In fact, a coronal mass ejection back in March 1989 blacked out Quebec and large parts of northeastern North America for over 12 hours, leaving millions of people in the dark. Meanwhile, astronomers are also monitoring a large new sunspot group that's just rolled into view over the Sun's northeastern limb. Catalogued as AR 3112, it already has a mixed polarity magnetic field and more than a dozen dark cores stretching across 130,000 kilometres of the Sun's photosphere, harbouring enough energy for multiple strong X-class solar flares. Its appearance could herald 2 weeks of high solar activity as it transits across the Earth-facing side of the Sun. Now, all this increased solar activity we're seeing could be just the beginning as the Sun moves into a new 11-year solar cycle. The new solar cycle 25 is already proving to be far more active than expected, and astronomers are speculating that it could be a record setter. The good news is the increase in space weather means the spectacular northern and southern lights, the aurora borealis and aurora australis, should be more active over the next decade or so. This is SpaceTime. And time now for a brief look at some of the other stories making news in science this week with the Science Report. The 2022 Nobel Prize in Physics has been awarded in Sweden to Elaine Aspect, John Clauser and Anton Zellinger for their work in studying the odd and unusual entangling behaviour of quantum particles. Defying the logic of our everyday reality, these particles behave like a single unit even when they're isolated from each other a long way away with no means of communications. Engineers are currently working out ways of harnessing this spooky behaviour at a distance, as Einstein called it, for a range of revolutionary technologies, including quantum computing and quantum cryptography, a supposedly unbreakable technique of secure information coding. Meanwhile, the 2022 Nobel Prize for Chemistry has been awarded to Caroline Petozzi, Morten Meldal and K. Barry Sharpless for their development of click chemistry and bioorthogonal chemistry. Sharpless and Meldal laid the foundations for this functional form of chemistry, in which molecular building blocks snap together quickly and efficiently. Petozzi then took this click chemistry to the next level by utilising it in living organisms. And the 2022 Nobel Prize for Physiology or Medicine has gone to Svante Pääbo for his pioneering research in sequencing the genome of the Neanderthal, an extinct relative of modern-day humans. He also made the sensational discovery of a previously unknown hominid, Denisova. Pääbo also found that gene transfer had occurred from the now extinct hominids to Homo sapiens following migration out of Africa around 70,000 years ago. This ancient flow of genes to present-day humans has physiological relevance today, for example affecting how our immune systems react to infections. Raytheon and Northrop Grumman have been selected to develop a new scramjet-powered hypersonic missile for the United States military. The HACM, or Hypersonic Attack Cruise Missile, will be designed for atmospheric flight at least 5 times the speed of sound, using a combination of Australian and American supersonic ramjet or scramjet technology. A solid rocket is used to launch the missile and then accelerate it to supersonic speeds. And that's where the scramjet engine kicks in, taking over and using the aircraft's high speed to forcibly compress incoming air before combustion, which then enables sustained flight at hypersonic speeds. By travelling at hypersonic speeds within the Earth's atmosphere, HACM will be able to reach their targets more quickly than similar traditional missiles, which use ballistic trajectories to often take them out above the atmosphere. Now add to that, HACM will also have manoeuvrability at hypersonic speeds, and that combination makes them virtually unstoppable, able to evade even the best anti-missile defence systems. The new missiles are being developed in coordination with SciFire, the Southern Cross Integrated Flight Research Experiment, a joint Australian and United States aerospace scientific research project. As well as hypersonic cruise missiles, the two nations are also working together on new hypersonic glide vehicles. That involves a missile being accelerated to hypersonic speeds by a rocket, then released to quite literally ride the top of the atmosphere or glide the atmosphere to its target. But it's a case of playing catch-up. You see, Russia's already begun equipping their armed forces with their new Zircon hypersonic scramjet-powered cruise missile, which is capable of around 9 times the speed of sound and has a range of over 1,000 kilometres. And the Kremlin recently unveiled another new hypersonic cruise missile they call the Kinzhal, claimed to reach Mach 10, with yet a third design, the Avant-Garde hypersonic glide vehicle, which is boosted by a rocket and can apparently reach Mach 27. And Russia isn't alone. China have their own hypersonic cruise and glide missiles. There's the Xingkong 2 Wave Rider and the rocket-powered hypersonic glide vehicle, the Dongheng 17. A new study has found that petting your dog or cat seems to boost a part of your brain that helps regulate the process of social and emotional interactions. Research measured activity in the prefrontal cortex of 19 people as they each interacted with a little puppy. As a control, these same interactions were measured using a stuffed toy animal named Leo. The findings, reported in the journal PLOS ONE, showed greater activity when people interacted with real dogs and cats, and this difference was largest when people were patting them, instead of when they simply looked at the animal or when it reclined next to them. Well, it might not seem like an obvious perfect match, but it turns out smart speaker assistants like Alexa, Google Assist, and Siri can come in really handy during Halloween. The mischievous Tim Mendham from Australian Skeptics says Alexa's features now include scary parlour tricks, grim guessing games, ghost hunting expertise, spooky storytelling, and even some pretty unsettling audio, including some spine-chilling screams and ghoulish whispers.
Of course, Amazon's Alexa, which is a smart voice assistant to do things, and it can help you do lots of things, apparently even buy things, which it does of its own bat, has a lot of functions on there which probably a lot of people don't know about, which is sort of scary, ghosty sort of stuff. For instance, if you ask it to, and you can schedule the Alexa to scream at a certain time. So you say, Alexa, put out a scary scream in 15 minutes, and then you walk away and you gather all your friends and things in there, and you're sitting down with candles lit, etc., and trying to tell ghost stories, and suddenly this scream will happen, and naturally everyone runs out of the room.
That is so cool.
That's one thing. It can do all sorts of, it can play games, it can do, tell spooky stories. It'll whisper, make little whispering noises like, hello, whispering noises that you hear over your shoulder. And so all these things that you think, why would you want it in the first place? It's a game stuff. But they're saying that obviously what it leads to is that some people think it's actually, okay, it's the Alexa, but there's something behind it, that there really is a ghost thing behind it. You just don't know. This is like people who say you're really a psychic, but you don't admit to it, which they say to skeptics. And these ones are saying Alexa really is haunted because it does all these things, but you tell it to do these things. One of the nice things about the customizable ghost stories it tells you is you can put your name in there. It will include your name in the ghost story. You know those books you get where you can get the kid's name in the book, and then, Billy did this and Jane did that.
Yep.
Ran down the road, etc. It's much the same as that. So if you want your name, and Billy got haunted by a ghost and had his head chopped off, it could be an interesting thing. You can use it to scare people and perhaps convince the unwary. It'd be a good little trick for a psychic, wouldn't it? You're sitting around looking at their crystal ball and suddenly you hear this whispering sound. That'd be rather cool. Not real, but it'd be cool.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.